Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. So we are at the final video for chapter 2, part B, frequency modulation. We will discuss some example question and solutions for that. Okay, example 1A. Determine the peak frequency deviation and modulation index M for an FM modulator with a deviation sensitivity K1 equal to 5 kHz per volt and modulating signal Vm equal to 2 cos 2 pi 2 kt. Okay, the solution: determine the peak frequency deviation delta F equal to K Vm over 2 pi. So just input the value for this equation. So K equal to 5 multiplied by 2 Vm to divide by 2 pi. So you'll get the answer. The modulation index is MF equal to delta F over Fm. Delta F given here up this question, divide by the frequency, modulating frequency 2000 by 2000, you get the answer. Okay, next. Example 1b, determine the peak frequency deviation for a modulator with a deviation sensitivity K equal to 2.5 radian and modulating signal Vm 5 cos 2 pi 2000. The solution: just input the value into the equation. Delta F, frequency deviation delta F equal to Kvm over 2 pi. K is 2.5, Vm is 5, divide by 2 pi. You get the answer. Example 2. For an FM modulator with a modulation index M equal to 1, a modulating signal Vm equal to Vm sine 2 pi 1000 T, and unmodulated carrier signal 10 sine 2 pi 500 K T. Determine number of sets of significant side frequencies, their amplitude. Draw the frequency spectrum showing their relative amplitude. Okay, the solution: number of sets significant side frequencies given that modulation index equal to M equal to 1. Refer to Bessel table. Significant frequency is 3 pairs or 3 sets. So M equal to 1, the significant side frequency is 3 sets. B, the amplitude. From the Bessel table, when M equal to 1, J0 equal to 0.77, J1 equal to 0.44, and J2 equal to 0.11, J3 equal to 0.02. Therefore, all the relative amplitude need to multiply by VC. VC is 10 volt. So we multiply, we get J0 equal to 7.7, J1 4.4, J2 1.1, and J3 0.2 volt. Draw the frequency spectrum. So this is the spectrum. We have the frequency and the amplitude. So the amplitude multiplied by VC. So this one is 7.7, 4.4, 1.1, and this is 0.2 volt. So FC is 500 kilohertz, and you have here 501, 502, 503, and this one is 499, 498, and 497 kilohertz. Unit is kilohertz. So the bandwidth of significant spectrum is 6 FM, which is 6 multiplied by 1 kilohertz, 6 kilohertz. Example 3. For an FM modulator with a peak frequency deviation delta F equal to 10 kHz, modulating signal frequency FM 10 kHz, VC 10 volt, and FC 500 kHz. Carrier. Determine actual minimum bandwidth from the Bessel function table. So bandwidth from the Bessel function table, you need the value of modulation index. So modulation index can be calculated from this equation, delta F over Fm, delta F given 10 kHz, Fm is 10 kHz. So you get the value of molten index, which is equal to 1. So from that, we can calculate, from the Bessel table, you can get the value of significant side frequency, N, which is equivalent to 3 previously. Okay, so we have seen that when M equal to 1, then you will have 3 significant sideband. So you get this value 2. So the bandwidth is 2 multiplied by 3 to 3. Fm is 10 kHz, so 60 kHz. Approximate minimum bandwidth using Carson rule. Carson rule is 2 delta F plus Fm. So 2 delta F is given 10 kHz. Fm is also given 10 kHz. So approximation bandwidth using Carson rule is 2 multiplied by 10 plus 10, 20. So you get 40 kHz. Plot the output frequency from the Bessel approximation. So this one, we plot the same frequency spectrum from as previous question. Determine the unmodulated carrier power for Fm modulator and conditions given in example 2. Determine the total power in angle modulated wave. Okay, can do that. Okay, this one is example 1 as we have discussed before. Determine the peak frequency deviation. So this is the equation, delta F K1 Vm. So you calculate, you get 10 kHz delta F, and the modulation index is delta F over Fm equal to 5. Determine the peak phase deviation for PM modulator with a deviation sensitivity equal to 2.5. So this one, given this equation, M equal to kVm in unit of radian. So we don't need to divide by 2 pi. So just multiply straight away. Example 3. For Fm modulator having a modulation index M equal to 1, this is again, we have discussed this before. M equal to 1, 2 pi 100 1000 T Vm, and Vc 10 sine 2 pi 500k. Determine number of sets of significant side frequency, the amplitude, and draw the frequency spectrum. So from the Bessel table, we have M equal to 1, so we get J0 0.77, J1 0.44, J2 0.11, J3 0.02. So there are 3 pairs of significant frequencies. And for the amplitude, J0 multiplied by Vc, J1 multiplied by Vc, J2, J3, all those multiplied by Vc. So we get the real amplitude of the side frequencies. Okay, so this is also discussed. So this is the answer. Determine the deviation ratio and bandwidth for worst case widest bandwidth modulation index for FM broadcast band transmitter with a maximum frequency deviation of 75 kHz and a maximum modulative signal frequency of 15 kHz. Determine the deviation ratio and maximum bandwidth for equal modulation index with only half the peak frequency deviation and modulating signal. So dr equal to delta F over Fm. So given the value is given 75k over 15k equal to 5. For m equal to 5, we can see from the Bessel table that n equal to 8. So m is the modulation index, n is the significant side frequencies. So the bandwidth is 2 pi fm, sorry, 2n fm equal to 2 multiplied by n, which is 8, multiplied by fm, which is 15k. So we get the 240 kilohertz bandwidth. Delta F is 75k over 2, which is 37.5 kilohertz. Fm is 15k over 2, which is 7.5 kilohertz. So dr 37.5k over 7.5 kilo equal to 5. The bandwidth is Fm is half of that, of this situation. So we can see that the bandwidth for the second case is half of this, the first case, which is 120 kilohertz. For FM modulator with a modulation index m equal to 1, a modulating signal Vm sin 2 pi 1000 t, and unmodulated carrier 10 sin 2 pi 500k. Determine the unmodulated carrier power for FM modulator given with a load resistance RL equal to 550 ohm. Determine also the total power in the angle modulated wave. So PC equal to 10 square over 250 equal to 1 watt. So PT equal to 7.7. This is what? This is the amplitude of J1. This is J1. Sorry, this is J0, J1, J2, J3 square over 2R. So this is R. So you get 1 watt. For FM modulator with modulation index m equal to 2, okay, assume this is the load 50 ohm. Determine the number of set of significant sideband. Determine the amplitude. Draw the frequency spectrum showing the relative amplitude of the side frequency. Determine the bandwidth. Determine the total power of a modulated wave. So the question is almost similar, but this time m equal to 2. So refer to the Bessel table. We get the value of n and the value of j. J0, J1, J2, J3, and J4 from the Bessel table. So what happened is the amplitude of the side frequency, we need to multiply j with the value of Vc. So this, when we multiply, we get the value of the amplitude of the side frequencies and also the carrier. So from this, bandwidth is 2n fm. So 2n is n equal to 4. Fm is 2k. Fm is 2 kilohertz. So from this equation, we input the value, then we get the value bandwidth equal to 16 kilohertz. PT equal to P0 plus 2 P1 plus 2 P2 plus 2 P3 plus 2 P4, because P0 is this one, P1 we have 2 sideband, okay, P2 also we have 2, and so on and so forth. So plus everything, we got 1 watt. Determine the deviation ratio and worst case bandwidth. So we have discussed this before. Dr equal to 2.25 kilohertz frequency deviation over modulating signal FM 12.5 kilo, which is equal to 2. So bandwidth is 2 and FM 2, and when this modulating index equal to 2, so you can have this n equal to 4 from the Bessel table. So 2 multiplied by 4 multiplied by FM, this FM. This, so we get bandwidth equal to 100 kilohertz. For an FM modulator with 40 kHz frequency deviation and multi-signal frequency 10 kHz, determine the bandwidth using both Carson rule and Bessel table. MF equal to frequency deviation delta F over 10K is FM, the modulating signal frequency FM equal to 4. When M equal to 4, from the Bessel table, we get significant sideband equal to 7. N equal to 7. So from the Carson's rule, bandwidth equal to 2 delta F plus Fm. So from this, 2 multiplied by 40k plus 10k, which is 50, so equal to 100 kilohertz. Bessel table bandwidth equal to 2n Fm, 2 n equal to 7, Fm is 10, so equal to 140 kilohertz. This is a conventional way of calculating bandwidth from Bessel table, and this is the approximation of the bandwidth calculated using Carson rule. For FM modulator with an unmodulated carrier, amplitude 20 volt, a modulating index M equal to 1 and a load resistance of 10 ohm, determine the power in the modulated carrier and each side frequency, and sketch the power spectrum for the modulated wave. So P equal to P naught is 20 multiplied by 0.77 square over 2 multiplied by 10, so 11.85. So same, using the same equation, we can calculate the power at the sideband, side frequency. So P1 equal to 20 multiplied by 0.44 square, 2 over 10, 3.872 watt. Okay, so this is the spectrum, this is the carrier, first frequency, second frequency, and third frequency. Okay, that's all. Thank you very much.